on like getting their work turned in and revising their work and stuff like that. So I'm prioritizing their stuff. Sorry. You guys are more responsible. I mean, last year was totally broken, so it's really hard to compare to last year. Jake, have you turned in Chapter 1 practice yet? Do I need to be that teacher that walks over and closes your Chromebook? Because I have a feeling you're not going to stop unless I force you to. Yes, yeah, closure counts as homework. And closure answers are in the book, too, just to say that out loud again.
I think I split my closure up across multiple pages.
I did that. So
I see, because I ran out on one page.
Yeah, that's what I did.
I was like, why did I do this? Am I just weirdo?
Am I just a weirdo?
Should it be in, like, order?
Yeah, if you want to be nice to me.
Be nice. He probably has a lot of things.
I would assume you have around like 80, because there's about 87 pages. Although some of them have mysteries, but probably haven't at all.
So, question.
Here you go.
Oh,
Bro.
yeah, no, staple it
Straight
together.
in your papers, line up your holes, make sure there's a name at least on one of them,
We want to order from
and
them.
staple them. So, non-math related question. Have you guys heard about the TikTok challenge about like destroy your school bathroom?
Oh, Miss Evans was telling us about that and how she hates it.
Okay, well, first off, don't,
Oh, people aren't.
right? Second off, if you see anything sus happening, like involving other students, you know, those other students, make sure you let us know
Those other students.
ASAP, so we can take care of it. Mr. Combs was making a really good point, which, man, you guys never got to have Mr. Combs, which is sad. But he was like, what? My goal in the bathroom is touch as little as possible. Like, because bathrooms are just kind of gross. He's like, the last thing I would want to do in a school bathroom is, like, touch everything. Just how he talks is just really funny. All right, so now that we've got stuff turned in,
Wait, I don't. I'm holding up the tray.
such
I had to
such
organize.
suspense. What? Why aren't your papers just organized in your binder?
I don't know. They were like semi-organized.
Maybe next chapter we can have that as a growth target, right? Keep ourselves organized.
Well, they're all like in the homework section.
Oh, that's a start.
Oh, here's the stapler. Okay. Wait, they're not lined
That's the
up.
nice stapler too.
How is it nice?
You use it, you'll know.
Do-
It's stapled
do the
25 pages at
The
a time.
holes need to be fully like.
Nah, it's fine. I mean, if you want them lined up, so when I give it back to you, you can put it back in your binder. But I will also give you guys a spot in a filing cabinet very soon. I just have to figure out where that filing
A
cabinet is.
filing cabinet? That sounds fancy.
Yep, so you can keep your stuff in there instead of having a full binder. So we know certain similarity.
Wait, I forgot to put the closure in.
This is gonna be like the 5th time that I've tried to start class.
Silly Connor.
This is why teachers that write out like at this minute I'll do that and at this minute I'll do that, those teachers are silly. They made us do that in college. Like the intro will take 3 minutes. The first question will take 5 minutes. The next which you should have a relative plan in your head like that, but you gotta be flexible, right? For students like Connor. Hey.
Fair point.
Fair point. I like to tell people if you get defensive, it's probably true. Like when my friends get mad about something, I'm like, if you're defensive, it's probably true. So, in A, we're lacking one piece of information, but I'm betting that you guys are going to tell me pretty quickly that we're not really lacking much of anything. Who wants to talk to me about A? And luckily, there's 3 of these, and there's 3 of you.
Well, the 2 legs are not congruent, so the hypotenuse can't be congruent.
So, remember, we're not looking for congruence.
Oh, for similarity?
So, we're really investigating the what? Blank blank. Something factor.
Proportional relationship.
Sure. scale factor, right? So if it's a proportional relationship, the scale factor stays consistent. Do we need to solve the hypotenuse here? No, we already have enough information to compare because we're really relating side angle side, right? Because they're both right triangles. Excuse me, now Connor, you had an interesting assertion that I want to circle back to later. Connor said, because we were chatting about the lockers this morning, he said, I'm pretty sure side-side angle works if the angle's obtuse.
Because it works for a right triangle, and I think the same logic.
And I'm curious if the reason that would work has to do with what else you restrict when you force that angle to be obtuse. I'm curious about that. I kind of want to circle back to that later. So here, we have side, 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 right, in B. So somebody not Jake.
Sure.
You don't think they're similar? Why is that?
Because 14, and so the scale factor is 1/2, and then 1/2 of 9 is 4.5.
So we see a 1/2 between the 8 and the 4, a 1/2 between the 7 and the 14, but not between the 9 and the 5. So Connor, you get C, which is appropriate C for Connor. What about this triangle?
It shouldn't have been
I
D
get the
for
best
O.
one. Oh. What?
You get the hard one. Half the
Wait.
This is when we get to start using the stuff that we have learned.
Angle, side, angle.
Hey,
Whoa, that's a bad word.
Yeah.
Like,
You just use the dilation.
You just used that. Did you?
we have
All because you added a sound effect does not make it right. It does make it better, does not make it right.
But that is right.
You can't-
dilate from point M.
So, I agree with you, but we have to mathematically justify why we know that this was a dilation performed properly. Right? Because, remember, people can do stuff wrong. You can tell somebody to dilate something and they don't do it correctly. So,
the angles are congruent.
okay, Connor, if the angles are
All
congruent,
angles are congruent. It's angle, angle, angle.
That's true.
so if corresponding angle, well, we don't even care that they're corresponding right now. If V is congruent to S, and if M is congruent to M, right, reflexive. So this is given, right, V and S, so we know V and S because it's given. We know M and M because reflexive. How do we know T and M? Triangle angle sum theorem.
Yeah.
Sweet. Now what if I tell you you can't use triangle angle sum theorem to prove this?
Well, and it's also easy because
Oh, sorry.
angle, side, angle. Because you have that those two angles are the same, and then you also have the side. Wait, does angle, side, angle work for similarity? Yeah, I think it does. And then you have the side is
Angle
the
side, angle
same
side, easiest one.
side.
What if I tell you you can't use this angle?
What angle?
M.
But they're triangles. If I can't use angle, then it's not triangle.
No, it's there. You just can't talk about it. It's having a day. It just wants to be left alone.
I also have a friend of mine.
So this is where I'm going to start to push your brains, even though it's not necessary here, to observe what we see and then figure out, oh, what do we know because of that? MV looks straight, so it is straight. We said, like, in our book, we've agreed that a line that looks straight is straight. And we have these corresponding angles. So if we have congruent, so this serves as our transversal, and because of those congruent angles, those two lines have to be parallel, which then
means the
means,
T and N are complementary.
which then means congruent. You were both wrong. That's funny, because you guys are like never wrong.
They are complementary.
What do you mean?
Complementary means add to 90. Remember? They're
Yeah.
corresponding.
That's what I meant. Same
Yeah,
thing.
wrong seat.
No, it's-
Not the same thing. This is a math classroom, thank you very much.
And then, wait. And then we have the sides scale. So,
So then, because these lines are parallel, we know M must be a center of dilation. Because if these angles are congruent to each other, I should actually probably put a second tick mark. And these angles are congruent to each other, and they come from straight lines, like they must be proportional. Like this must be a dilation. There we go. And we don't even need angle M. We got the point.
See, you didn't
Right.
need the
Wait.
shoot.
Whenever you draw like the angle arc and then the two tick marks on it, it reminds me of a ball turret.
Oh, what?
Like those things in the bottom of planes, like the clear balls.
Oh, yeah. I think, I forget what movie and I forget what characters. I don't really remember much, apparently. It's in a Marvel movie. They're flying like an old plane. And
Captain Marvel? I think there was a plane in that.
I don't know. I get them all mixed up.
Captain America?
I think there was a plane in that. Wait, Wonder Woman? I think there was a plane in that.
That was a Marvel movie, though.
Ooh, got me. Got me there.
Fun.
All right, for the diagrams in 290, what are the lengths of this? Oh, crap. Write down JK, VT, and TN, because now we got to go back to the other slide and find lengths.
Oh, shoot.
JK, VT, and TN. Crap. We thought this was easy.
Wait, what were the angles?
JK,
Yeah.
Right?
Oh, it was TN?
have at it.
Yeah.
What's Jake? Oh, from the top one.
From the top. Actually, I got my music joke.
Yes. I enjoy it. I don't enjoy it.
No, it's
Oh.
fine.
I played the video for my wife
Wait, you
when
did?
I made the tutu joke, and she just shook her head so hard. It was. Then I was proud of myself.
Jake, the first one.
No! Don't put it that. No, don't do that.
Jake, it's 15.
If you're gonna write it that big, can you at least wait? How do you know it's 15?
Jake, you don't know the fact is you can use the scale factor.
Wait, can we?
Yes.
Yeah, because we know the triangles are similar.
We do.
And we know their scale factor.
We know they're similar.
Yeah, angle, side angle. Or side angle, side. What?
So it was our scale factor there then.
Well, depends. 3/4 or.
What do you mean? Oh, which way we
Depends
go?
which way you're going.
So you said it's either 3/4 or or the reciprocal. Do we need to use 3/4 or 4/3 to get to JK?
Technically, we could use either.
Okay, we could either divide or multiply. So yes, technically, math has lots of options. Great, we're all smart in here. So, see, it's not so funny when it happens to you, is it?
That's how I do that.
So wait, hold on, step back for a second.
Okay.
What is VM?
VM is 11.5.
11.5. So what we're really comparing is 11.5 to 9.
Do you have some?
He's very proud of himself.
Wait, why are you there?
At least like.
I guess that works.
Okay.
I
No,
can't
not
read
read that.
anything that you have written.
Is
there.
it X plus 11?
Yeah.
That is not all.
No, make it do the circle thing. I haven't gotten to do it yet.
It is.
Or, like we talked about yesterday, if there would be a way to relate the 2.5 to the 9,
No!
but those don't work very nicely.
We can just do 11.5 divided by 9.
So you could. Yeah, if you just want to find out the scale factor. Is that a nice number?
No.
Where's the other pen?
So you could also do 115 divided by 90. Here.
Oh, 115 divided by 90. Yeah, that would work. Or we can do it that way.
1.2777 repeating forever. So
Yeah.
that's not very
1.
nice.
1.2 and wait, that's not how math works. I was gonna say 1.2 and 7 times, but that's not right. 790?
So wait, x plus, oh man, that seems kind of complicated.
Well, you can
Is there a
use-
nicer way we could write the proportion? With, like,
Yeah.
x plus 11
We
seems bad.
could do it with a horizontal.
Well, yeah, so of course there's a nicer way we could set it up, but I mean numbers that are nicer.
Just x.
Do we have to use x plus 11?
What is that?
That's an 11. Don't judge.
X. But is that?
Grab a seat real quick.
Now it looks like 70.
Grab a seat real
I
quick.
don't think that works.
Grab a seat real quick. Jake, challenge, solve this proportion. No, at your desk, because then I'm going to write something else up here. The
Okay.
proportion that you keep saying that you want to use, solve it.
Wait, which one? X plus 11?
Sure.
Okay, it's... No, it's not 2.5. I think it's 9 over 11.5.
I'm not solving yours. You're supposed to be solving it on paper.
Oh.
I'm doing something else to test out a hypothesis.
That's what I was gonna do.
Do it then. Do it so you can check my math and hold me accountable to make sure it's right. Because right now I'm struggling to do this.
275, 25.7.
Close. You got
Oh.
dyslexic.
Oh, right, yeah.
That's not gonna be a nice number though.
Question is, does it work?
It should. Well, it won't tell us what TMN is. It'll tell us what TM is, and then we can subtract 11 from it. And then
Wait, what will this tell us?
it'll tell us what TM is.
TM or N?
TM.
Because I get 3.05 repeating forever here.
I think that's 10, yeah.
Oh, never mind. Yeah, it's TM. Yeah, never mind. This wasn't what I was gonna do. It's similar, but
Yeah, I get 3.05 repeating forever too.
Oh, yeah.
So, this idea that I brought up yesterday of not having to look at the entire side length, because that kind of complicates our proportion. Instead of using x plus 11, which we could, right, that's an option. But instead of using the entire side length, we can really just say extension compared to the original is proportional to extension compared to the original.
Yeah.
Yeah. So we don't need to use x plus 11.
That's what I just wrote up there.
You kept writing x plus 11.
No, but then I wrote that.
What I saw was scribble, 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 scribble.
That's what I
So this is why I wanted to make sure I guide you to
I
see
have bad
that
handwriting.
this way works.
It's also because you use a really thick font.
yeah.
I don't think bad handwriting matters when you're writing this big.
Is that fancy
All right.
handwriting? I can't tell.
So Cameron offers you a challenge. Are these triangles similar?
Correct,
Correct. Yes,
yes, they are.
they are.
Jake, why do you think they're similar?
Yeah, they're congruent.
What? Are they congruent or similar? Wait,
They're congruent and similar. You're side to side. Wait, okay.
Yeah. Okay.
Oh, okay.
We discussed this yesterday. What is Cameron trying to show us here?
Congruence equals similarity plus more stuff.
Yeah, I mean, regardless of the fact that these are also congruent, that's like a little bonus. But like, what is this iterating? Are these triangles facing the same direction? I guess I'll ask that
It's
question.
iterating that orientation does not matter.
Yeah, orientation is irrelevant for proving similarity or congruence. So just order of side, or angle, side, or... So, I wonder if we can find an example to test out your angle, side, or your side, angle, side.
Wait, what's that DT again?
VT.
We didn't calculate
I never
VT.
calculated that.
Okay.
What?
We didn't calculate VT.
For shame. Were we supposed to?
It was one of the three.
Uh-oh. Uh-oh.
No, Connor.
Hmm.
I
Hmm.
honestly don't think there's any way to do it.
Hmm. What were you saying, Connor?
What? I don't think we know any way to do it.
That's a defeatist attitude.
It is, but I think it's true. I don't think we've been taught how to do this. I don't remember.
Trig. Something about trig, but we don't know the
I
angle
think-
measure.
No, wait, what's trig?
It's for
Yeah,
right
what is-
triangles.
I know there's a theorem to figure out.
You went from excited to sad.
I think there's a theorem.
Well,
I
it's our right here. Wait,
that if you use the
It's not a right
I don't.
triangle.
There's a theorem
Oh,
for
it
it, but
could
I
be,
can't
but we know
remember.
yeah, okay.
Oh, I was like trying to break the desk.
Right.
So,
Yeah.
guys, is everything like? I don't even know how to ask this because I don't like defeatist attitudes.
Solvable?
Yeah,
Possible? A good idea
No.
to try and solve?
yeah, like we can't solve for VT right now. What would we
Aha, so
need?
you admit it.
What would we need to solve for VT right now?
The angle the line measure of SN.
Ah, if we had SN, we could do it. Or Jake brought up. What'd you bring up? What'd you bring up? I said. Then I asked a question, and then you got sad. You brought up trig. So, but trig involves right triangles. So if
This
we-
could be it, right?
could drop, why are you still not?
It could be, yeah.
If we drop something, well, but then we would still need to know angle measure, right? Because trig involves. Well, wait.
Well, we could just use the package here if we knew it was the right time.
If we knew trig, trig finds out the angle measures.
Based on the side lengths.
So if we know the side lengths, we can figure out the angle measures. And then if we know the angle measures, we can figure out the side lengths.
Wait, what's
Right
Huron's
triangle.
formula?
What?
Huron's formula.
Like Lake Huron?
No, Huron. No.
That was probably.
Okay, so yeah,
Cameron?
okay, yeah, that's what it's called.
Trust me, you don't want to use that right now.
Oh,
It's real bad.
I don't like it, but isn't that no? That's finding the area.
Does what you're looking at look nice?
No.
No, it's bad. You don't want to use that yet.
Still-
All right, last challenge of the
I
day.
don't even know what that is.
Last challenge of the day. Because this gets us through this lesson, and there's no reason to hammer down on the gas this much.
Cat, run.
Wait, oh, they're not right triangles, though, which is the tricky part. I think, yeah.
Jake,
Yeah, they're congruent.
we can sing in a minute when we're done with
No,
this.
they're
program.
not congruent.
No, they're not congruent. They're similar. They're similar. They're similar.
Maybe if we weren't singing at the same time, our brain wouldn't be mixed up.
Ron is similar to Cat.
Ron? Oh my gosh!
But we don't know why. Because it
Yes, we do.
can't.
It's side angle
Wait,
side.
Ron? There's no O.
Ron is side.
Ron, oh,
Ooh, wait! Obtuse angle.
Yeah. I was
Do you want
not-
to test out your...
Well, we already know because we know the one angle.
Well, sure, but this is how we can test out. Does it work? So what if you only knew your obtuse angle and two sides?
Yeah,
Well, can we figure out TA? If we say that these are similar, can we figure out TA?
6.15.
Oh, right.
Oh.
Ah, like a scale factor of a half, right? Half to here, half to here. So then we realize this is...
And then we can figure out all the other angles.
Well, we can figure it out.
Angle T and angle N are 30 degrees, and angle U is 103.
Is it 30?
And then, yeah. And then angle U is
103. Not 107. Why is 0 called O sometimes?
Called what?
Like O?
because
It's also called
it's an
love.
O, but it's like
has-
skate.
It's called a bunch of
But
things.
like, that's confusing if
It's
you
also
say
called like nil and zilch.
those are just made up.
Yeah.
But But
All
it's
words
also
are made
called-
up.
Yeah, I know.
It's called love in tennis.
So the only thing I really figured we might take time on this for is if we wanted to theorize. If we wanted to theorize, does angle side ever work?
I think it does for.
Well, for right triangles, we actually changed the name of it then. Hypotenuse leg.
I think for obtuse triangles it works too. This is my theory.
So if you had, let's say, let's circle in green what we're gonna hypothesize here. This angle and then two adjacent sides, which would mean the 103 to the this and the this, right? If that was all the information that you knew, what do you think?
So wait. All we know is stuff in green.
Yep.
We can say that they're similar. Oh, wait, no.
Why can't we say that they're similar?
Because it's angle side side.
Yeah,
But with the caveat of obtuse angle.
why can't we say that they're not similar?
What do you mean?
I think they have to be similar.
Good
Oh
challenge.
yeah, I think they do have to be.
So if what Connor's trying to prove is that yes, this works, he then challenged you, okay, if you want to say it doesn't, prove that it can't show similarity.
I mean, obviously it can because it does.
Okay, so then can you break it? So sure, it does, but can we break it?
Try something.
Please don't use a thick marker. Please use a small one, please. Use a okay. Now the ball.
Crossing out all the angles, everything we don't know.
I need to focus.
Yeah, everything we quote unquote don't know.
The green circle is a full circle.
Alright.
And a goal.
So we don't actually know.
Let
that
me
it's
think.
similar.
Let me think. Okay.
See?
So essentially what we're wondering is like, could we change an angle and keep everything else?
Yeah.
Could we make
Or
the
the
third side not what it should be, but keep everything that's circled in green?
Okay, so we know this has to be the big angle. So that's the big side.
If you guys would like to play Fugitive or anything else, we can come back to this question tomorrow.
Moderate side.
I do not
goes with
plan,
moderate angle.
Jake, I'm going to tell you, I do not plan on giving you a definitive answer to this today. Or maybe ever.
Oh
And,
no.
do you know the answer to it?
Oh, that means you probably don't see it.
How? Wait. Wait, what?
Oh, I don't know if that works. I just did something.
You did.
I don't know if it works. I just did something. That sounds very
Okay,
mathematical.
why would it?
Wait. There.
What did you just say?
The way you ran like this.
Wait. That doesn't work with the scale path. Why?
Exactly, because they're not
Ruined.
Wait.
But-
But
silly,
okay, so
or they're not similar.
you.
All right, hold on, Jake. Don't lose us yet.
You
Are you allowed to write the things that you wrote? Are you allowed to write the things that you wrote and claim them to be true? We got to defend like,
No, I just guessed.
oh.
You said you said try to create a triangle.
Yeah, but I didn't say break math rules in the process.
What do you mean break half rules? I did it already.
Well, you just threw a 20 and a 30 up here willy-nilly.
Yeah, but then I made all of the angles out of for 180, and I made like the big angle will go with the big side, and the smaller angle will go with the smaller side, and then the smallest angle will go with the smallest.
Okay, so you followed some rules.
Might not.
So I wore my seatbelt, but I drove at 100 miles an hour.
Oh, no.
So what we need to wonder, right, and like this is setting up our thinking for the year. What are we allowed to do and not do based off restrictions that we have? The 103 keeps my third side pointing away, right? So I can't bend it in. The 16.4 and the 12.3 keep these two sides at those lengths. Can I open up this angle more?
No.
Yeah, but it won't intersect with the RU line.
You can close it
We
more.
don't know the
Oh, wait, no,
distance
you
of.
can't.
So wait, if I open this up more,
Hold up.
but keep it 16.4,
It won't make a triangle.
That is.
Right? Wait.
Dang it!
Take it.
dang it.
Uh-huh.
Care to explain?
Connor's right and I'm wrong.
Oh,
So wait, this does work?
Yeah.
So I need to erase some of the stuff that you put?
that makes it feel worse.
Oh, poor Jake.
Inside Connor's head. he's
But
like-
not really poor anybody if we're all learning, right? Like, that's a very teacher thing to say, I get it. But like,
there's one more angle and one more side.
I get it. Fix it.
I don't even know what this is. I'm just like,
It's supposed to be 47.
I thought
Wait.
it was
Okay.
78. It looks like a 78.
so are we potentially saying then angle side side does work if, like, little asterisks? So we already had the asterisks of if right angle, then really it's hypotenuse leg.
If greater than 89 degrees. Or if 90 degrees or greater.
You want a chance for vindication?
What do you mean?
If you ever find a triangle that we know is similar, that we know isn't similar, but follows angle side side, you're kind of wrong.
With an obtuse angle, I think.
This is what mathematicians do, guys. This is like everything that mathematicians do is like, well, mathematician Connor over here thinks that this is a theorem, right? He thinks he's got a conjecture, right? He's going to try to prove it. So mathematician Jake, just because he's got some chip on his shoulder, is going to try to disprove mathematician Connor just because it's fun.
Just because.
And if he can't, then we pretty much have to say it's a theorem, right? If we can't, if we follow the rules that we have, this is how things become theorems. So hypothetically, if this has been figured out before, we should be able to look it up, right? There should be some sort of angle side side with an
Unless Connor
asterisk.
was so smart and he figured it out himself, and he's gonna be so famous because he figured out that.
Do you know who made up anything? Don't say Pythagorean theorem. All things is the Pythagorean theorem.
I know lots of mathematicians.
Here's formula.
Actually, where is, do I have that? You guys would actually really like. This is a sweet book. If you're ever bored or need some print reading, gee, this would be up your alley too. The writings are like 2 or 4 pages. But like, so the second idea you need to understand about mathematics is number systems. If you look way back here, it's like all the different types of graphs and things like that. But it's all just like little 3 or 4 page snippets. And it gives you the timeline of when stuff was like
that's
discovered
cool.
compared to other things. So if you want to learn about other mathematicians, and if you want to learn about female mathematicians specifically, I have one of those books too. I just need to restructure my books and figure out where things are.
Wait,
It's either right here or over there.
I just read that.
What?
That's sad.
What?
Yeah, help! I'm lost and scared, all alone in this world.
Yeah, well, the binder got picked up and claimed. Now there's just a notebook there, lost and scared and all
Oh,
alone
that's
in
your
this world.
personal lost
Oh.
and found.
Yeah, that's my lost and found.
I thought that was for people that missed a day of class.
No.
That's